Hello guys. Uh, think my screen is visible to you all. Hello. Yeah. So let's start our session. So today we are going to learn how chatbot works and the whole workflow of the NLP. Yeah. So chatbot is a online conversation app where you can interact with the platform and the data within the chatbot itself. First chatbot was made by in 1966. Okay, so why we need chatbot is because there are some customer services where you have seen the ordering foods or ordering pizzas, or you have seen the customer care chatbots as well. And also chat gpt is also one of the chatbot which help to interact with the all of the data they are trained upon. Okay, so there are two types of chatbot: rules based chatbots and self learning chatbot. So what rule based chatbot is a simple chatbot which is trained on the like static is, questions and answers. Okay, so for example you can take the example of the food ordering chatbots, where there is pre already some questions and answers, where they take the data from the users and they do the workflow accordingly, either in the storing the database or ordering the food directly in the platform. Okay, so these are some of the rule based chatbots. And the self learning chatbots is made upon the machine learning algorithms. Some algorithms are TF-IDF vectorizers, count vectorizers, and what 2x, and RNN also is also used. But RNN comes in the deep learning model. So today we are going to build chatbot and some machine learning algorithms TF-IDF. Okay, so this self-learning chatbots are trained on some responses, questions, and all of the facts, and then so that it can deal with the new questions as well. But in the rule-based chatbots, the bot can only deal with the questions it is trained upon. If you give any random questions which is not already trained, then it won't answer at all. Like you can ask, like, I want to order a large pizza. Okay, the question is already in the database, but you tell that I want to order pizza, or I want to order pizza in 30 minutes. So maybe these type of questions are not already present in that rule based chatbots. So self learning chatbots are more better than rule based chatbots. Okay, so this is a workflow of the how chatbot works. Like you send the user message and then it classifies your message, and it breaks down into the intents and the entities. So intents are the intention you want to convey to the chatbots. Okay, and entity are some points, like in database entity are some classes or main variables where the on which the data is trained upon. Now, for example, if you want to order some food, then food is one of the entity on which the data is trained. Like if you will tell, like, I want to order a food, then it will give some options. You want to order which one of the food. Okay, and then the response selection is based on the similarity and also the semantic analysis as well. Okay, so the responses with the high similarity or the semantics will be given to the user as a response. Okay, so let me show you the workflow we are going. Yeah, so this is the workflow. I think this is visible to all. I will share the link at the end of the session. Okay, so first of all, we get the data. So we can get the data from as you want, either in the documentation format or in the or directly from the web Wikipedias as well. So we can use web APIs, or web scraping, or the text documentations like research articles, or the documentations provided in anywhere. Okay, so after taking the data, we can't directly do machine learning algorithm, apply algorithms on them. So we first need to clean the data. So if you do web scraping, you have some HTML tags in them which you want to remove. Also, like, you have some emojis. in some data there are some emojis which you don't, which the machine learning algorithms won't identify. Okay, so it will discard it. So not to discard, we use the Unicode normalization technique here, where emojis are converted into the unicodes. If you will Google, then you will get the unicode for each emojis which you use in normal text apps or chat apps. Okay, so first we will remove the all HTML tags, or we will convert the emojis. Okay, and also the spelling, some documentations may have spelling mistakes, or you have the documentation where in web scraping it mostly occurs, where some words are broken into several parts which are meaningless to use, so we remove them also. Okay, so after cleaning the data, we come to the tokenization part. Okay, so we have different ways of tokenization. So first one is the split function. We have used the split function in the Python, C++, everywhere, to split on the basis of the punctuations or any symbol. So that is a split functions we don't use for tokenization in general, because due to that, many important points, let's say you have a Gmail in that data, then it will tokenize, and it will it will divide the username and Gmail separately, and also some sentences which has commas in them. So taking the whole sentence, it will split into many other sentences which are also meaningless. So yeah, and also the regex. We can use regex for removing the HTML tags, or removing some unwanted data like numbers or any type of like Gmails. HTML tags are removed from the regex. But here we will use mostly NLTK or Spacey. So NLTK is a natural language toolkit where you have many methods like puncati, word nets, where you are provided pre-trained tokenization models in them. Okay, so one of them is puncati, where that is puncati tokenizer is a model which is already trained to tokenize the text nicely. Okay, and Spacey also behaves like the same, but Spacey is somewhat better than NLTK. In sense, I will show you an example. Okay, yeah. See, if you will do NLTK for tokenizing this sentence, then what NLTK do? It will separate your Gmail like this. So it's useless because this part of the data becomes useless to use. Okay, so what we use here, we can use Spacey as well. There is not much difference between Spacey and NLTK. Both handles the data perfectly, but there are some bugs in NLTK for which we can use Spacey also. Okay, and there are two types of tokenization, like sentence tokenization and word tokenization. So sentence tokenization divides your whole corpus or whole set of data into sentences, and the word tokenization divide the whole corpus into the words. Okay, now we come to the text pre-processing. Now till now we got the array of the words or sentences which are tokenized. Now we need to remove the extra things, so that what NLTK do now, it will take, I will show you, like it will take hello and hello as separate words, because this H is capital here. So NLTK will take this as a separate words, but the meaning is same. So we use lowercasing. So we lowercase the whole data. Okay, and we remove the punctuations also. Um, and also the URLs, because sometimes when you get the URLs now, it is either meaningless to use in the data. Okay, and we use the stop words. So stop words are like the verbs or the verbs thing, like and, he, and, the, a, is. So these are not used. Okay, now we come to the lemmatization part. So lemmatization is like, if you are taking two words like dancing and the dance. Okay, so they both have the same meaning. So what lemmatization do, it converts both into the same word. This is called root word or lemma. Okay, or this is converted if anywhere in the whole data set there are words like dancing, dance, dances. So these all will be converted into a single word dance, so that all have the same meaning. Only the difference is the tenses they are using, the dancing or the he danced. Okay, so tense doesn't matter here, as you are just taking or retrieving the information from them. So wordnet, what wordnet is, it's like a dictionary in NLTK. Okay, so you can add this wordnet has many English and many languages where you can put your data, so that it is also available for many languages as well. So yeah. Now we move to the machine learning algorithms we are going to use here. So in feature engineering, we come with the four algorithms for now: bag of words, word to vec, TF-IDF, and cosine similarity. So today we are going to use TF-IDF and cosine similarity. So what TF-IDF is? This is the main part. So yeah, so TF-IDF is a TF means for term frequency, and IDF is inverse document frequency. So term frequency is like the how frequently the term is appearing in the whole corpus or whole document. Okay, and IDF is the inverse document frequency, means how the whole term is appearing in all of the documents. Okay, so like you can take example, if some words are appearing in less number in there are five documents, and you have some terms which are appearing less. So terms appearing less have the more significant value. Okay, so this importance of priority is defined by TF into IDF. So the formula of TF is means term frequency is the number of occurrences of term in that document, in the particular document, divided by the whole number of terms in that document. Like you can say, I go to Delhi. There are four terms, and Delhi is the term we want to. So Delhi is one divided by four will be the term frequency. You can also say it as a probability. Okay, so probability also lie between 0 to 1, and term frequency also lie between 0 to 1. Okay, and the IDF is the total number of documents in the corpus divided by the number of documents with the term T in them. Okay, so like there are five documents in which three of them having Delhi. Okay, so their IDF will be 5 by 3 sorry, 5 divided by 3, log of 5 divided by 3, and then we will multiply the both, and then we will get the priority. Okay, so more the priority, more will be the importance of the word. Okay, so why we are getting this importance of the word, we will use the cosine similarity here to take out the most most similar word according to our questions. Okay, so like we are asked, the data is trained on the Delhi whole environment data is trained, and you're asking about Nagpur, then it won't answer you as the no data is trained on the Nagpur. So if so the data user or the request, or you can say the questions you will ask from the chatbot. So wait, yeah, according to that question, it will ask it, like it will respond you to the TF-IDF, the thing we got, it will compare both, and it will give you the responses. Okay. So let's move to the code part. Yeah, yeah. So these are some libraries we are going to use: NLTK, strings we are using to get all the punctuations. If you will do string dot punctuation, you will get all the punctuations we are going to remove from here. And random is to take from random we are using just for the greeting purpose. Okay, and warnings you are using just to ignore the warnings in the console, nothing more. Yeah, so here are the three libraries packages of NLTK we are using: Punk80, WordNet, and OMW. So Punk80 is for tokenization. It's already pre-trained tokenization module of NLTK, and it's very better. Okay, so you can use it. And for lemmatization, Lemmatization means dance, dancer. It will be converted to dance. That lemmatization part we are going to use wordnet. Wordnet is also a dictionary. Yeah, it is also a large lexical database. It's all like a dictionary part. Or OMW is also a wordnet, where it will. So we are using OMW so that the semantic relation of the words remain there. Okay, so like any word like rise and fall and donkey, there are semantic relation between rise and fall, but no relation between rise and donkey or fall or donkey. So it will take care of the semantic analysis of that. Okay, the semantic meaning will be there. So we are using OMW library, and also it is available for multiple languages as well, like Spanish or English or Portuguese. Okay, so here we are getting the document. I have made a model which takes just a document from anywhere document you can take. So I have taken document from the NLP. So I took from NLP Wikipedia. Okay, I just copy pasted the whole thing from here. No pre-processing. Okay, for now we will do every pre-processing step in the code itself. Okay, so we are taking the whole document here. Okay, a raw document, no pre-processing for now. Okay, so let's save it. Yeah, it's just for running the code. F equal to open, R for reading, and we are ignoring all the errors. Okay, so now we are lowercasing whole the document. Now we come to the tokenizing them, like dividing it into the words and the sentences. So for the sentence tokens, we have sentence tokenized method in NLTK package. Okay, so we will store the all the sentences separately in the sentence tokens. If you want to see what it looks like and run it. Yeah. See, every see every token is in the different. Yes, this is one token, and the other token starts here. This different tokens, the sentence tokens. Okay, similarly the word tokens will appear. But now we come to the lower lemmatization part. So NLTK dot stem is also a class in the NLTK package, and the WordNet lemmatizer is a method there in the stem class. So we will initialize the package. We will initialize the method. We'll store in the lemma variable. Now that we will make a function for lemmatizing the tokens. Okay, so this lemmatized token, and so this we will take every token from the tokens, and we will lemmatize every token. Okay, like we will take every word and we will lemmatize them, so that the if there is dance and dancer, it will convert into dance. Okay, we will take convert every token, the whole list of tokens. Now we will remove the punctuation. So this string dot punctuation is available there. Wait, I will show you what punctuation is storing. Yeah, see, string dot punctuation having these all the punctuation marks which you know don't need in the data itself, like these and all the punctuation which we don't need. So we are putting this in a dictionary. Okay, for now, and then we will normalize of the text after lemmatization. As the lemmatized this is the lemmatized text, and then we will normalize it. First we will translate the remove punct dictionary. Okay, then we will lower the case, and then what tokenized method, NLTK, what tokenized method we have already used here to tokenize every word. So this will just make a function out of that in the lemtize text. Okay, now this is the predefined board greetings. You can it's like normal Python. Like if the word in the responses, first we will split the word like in the spaces. Okay, now we will lower the words in the user response, because I told you like NLTK differentiate the capital H and the small h as two different word. So we have to lowercase every part of the data we are getting or we are giving. Okay. So now we will take the random choice from, this is just for the greeting hi hello from when the user comes to the bot. Yeah. So now this part is the machine learning part. Okay. So this is the user response we will get from the user, and this is the row bot response we will initialize by empty string or okay, and the sentence token which we got here. Okay. So I will say example like okay, so like these are the tokens we got. So these user response, as user response we get here is hello. Okay, so what will have, what it will do, it will append this at the end of the list. Okay, so append, what it does, it append at the end of the list, append at the end of the list. Okay, till here. Now what we will do, we will use a TF-IDF vectorizer, and the lem normalize is also a pre-trained lemmatization model. It's also a parameter of the TF-IDF methods. And stop word we will choose as a English. At stop word I told now to remove stop words from, to remove stop words here. Yeah, same thing here we are doing. We are removing the every stop words of English. If we are using the Spanish or any other language, we will change the language here, Spanish or anything. Now we are fitting transform all the sentence token we are taking. Okay. Now we are finding the cosine similarity. Okay. So now what will happen? This fit transform we are using here. So this will be converted into a, you can say a matrix. Okay. So like you have learned in one hot encoding. I will show you example. Yeah, one hot encoding you have seen that every word is converted into the different in the matrix or the array of digits, zeros to zero and ones. So similarly we will do in TF-IDF. So what it does, it converts the whole this every word into the matrix. But here is the catch, that if you have 30 words now, it will, the matrix will be of 30 dimensions. 30 dimensions, 3 dimension, 4 dimension, it will be of 30 dimensions. Okay, and this will be of 30 dimensions, and the last word, okay, let's say example, a short example I am taking, 0 comma 1 comma 1, okay, 1, and we are taking as 1 comma 0 comma 0, 0 comma 1 comma 1. Okay, so let's say these thing is converted into this. This is just 2 dimension, but 3 dimension. Okay, so but this will be converted into the how many words are there, it will be converted into that many dimensions. So now what this cosine similarity will do, it will take the TF-IDF vector. Okay, this whole thing is a TF-IDF. This TF-IDF is this part which we are sorry, TF-IDF is this part we are going. Okay, so this is the last part, this one is the last, and this is the whole list. So it will compare, or it will find the similar array uh, to this array. It will find similar to the last element of the array to the whole array. Okay, it will compare this one to this, then it will compare this one to this. So as it found that this is similar to this one. Okay, so this will return this array, it will return this array as an answer. Okay, it will return this array as an answer, and then again it will find all the similar words in the whole list. And it will again and again it will put it here. Oh, sorry. Yeah, where was, yeah, it will put the every, and then we will find the index of the most similar element. Okay, so we will first sort this all, and we will find the most similar element. So most similar elements will occur at the top. Okay, like least similar okay, sorry, most similar element will be occur at bottom, and the least similar element will be occur at top. So we are using argument sorting here for and then we flatten this the whole thing, and we again sort this one, and this is the final thing we are going to use. And so what it will do, this second last element we are going to use, like second similar element we are going to use. You can also use the first similar or third similar, fourth similar, and you can append in the whole one list, and you can return all. But I'm using the second similar element because it may be like data may be like that here NLP heading is there, and then it is telling NLP is a natural processing language okay, natural processing technique. Okay, so that's why I'm taking the second most similar here for now. Okay, so I'm just removing this all. So yeah, so it will take, if this one is not if this one is not zero, it will append it to the sentence token, that index of the sentence token, like it was the third index. Okay, it was the third index, so it will append to the response. This response we are having as empty string, the response, the most similar response will be appended to it. It will append every sentence, the here it will get the sentence at this index when sorted, and it will append it to the empty string. Okay, and this is the whole TF-IDF part. Any questions or any queries still here? Hello. Huh? Any questions from this part or any part? Okay. So we are setting the flag as true. Flag is true. We have set that the bot is responding. So we have set that response as true. And if the flag is true, we will give the input. Okay. And we will lowercase the every data we are giving or taking. All pre-processing will be lowered. Every data should be lowered. And if user is not exiting the bot, okay, or if user is telling thanks, like it will exit, you can change this logic according to you. If greeting, then we will give the greeting responses, greet function we have used earlier. Yeah, and if user is getting, if you user want to ask anything, so what we will do, we will take a word tokens. We will initialize a word token. We will tokenize every word of the user. Okay, and then it will add into the list. First of all, it will add into a set, so that all the duplicates words should be removed, and we will maintain a list for that to have the user responses words. And then we will take do the response function here. We will use like recursion you have learned, no? So we will use the you will store the bot response in the response, so that as it is working on every word. Okay, so after every word it will do the whole thing, and it will come here and it will append it to this one. Okay, so and the first response, if the bot response is okay, like if there is something response contained or is something similarity we got, then it will be contained in the bot response. And the first, okay, so this part is, if there is something in the list of the bot responses, we will send the whole thing, else we will send the bot response, which is this one, sorry, yeah, this one. Okay, we see the send the this one. I'm not able to understand you. And we will remove the user response. We added at the end of the listener, so we will remove that user response from the list. Okay, and this will occur again and again till you exit the bot using bye or goodbye. Yeah, so I will show you a demonstration. Let's take like Let's see if this is working or not. uh, we are taking anything like tell me something about Georgetown experiment. Yeah, so it's telling me about the Georgetown experiment. Okay, so this is how the whole workflow is going on. I will share the workflow link in the end of the session. Yeah, till here everything is okay. If you have any questions, then please can ask. Hello, any questions from the whole part or any part of the. This part, no? Okay. So if user is asking any question, let's say if user is asking this part of the sentence. So first of all, it will word tokenize everything, and it will tokenize and separate the whole word. Okay, and now it will put in a list, in a set. Okay, so what set do? Set is a data structure where duplicates can't be stored. Okay, if you store hello, hello, two hellos are there, but one hello will be removed from the set. Okay, so to remove the duplicates, we are using the set here, and the whole list without the duplicates we are storing in the final words. List of the without duplicates storing in the final words, and then this user response will be put in this response function. This will be this will run in the recursive way. It like for every token it will go here. It will add to the append at the last of the sentence token, which we have used here. Okay, like sentence tokens, like here every sentence will be divided in or separated, and it will be stored in a list, all the sentences, and the user response is a new sentence we are getting to the bot. So this user response will be appended at last of the sentence token list. Okay, and then it will be converted into the matrix. Okay, it will be converted into matrix like this, these type of matrices. It will be converted into the matrix. Okay, in of a number of words dimension, like w dimensions. Okay, so and now what will happen, you have the sentence token list having all the sentences, and your sentence at the end. So what it will do here, it will take your sentence which is last at the end of the list and the whole array. It will compare both of them, your sentence and the whole array, and it will take out the most similar sentence or most similar words out of that. Okay, and it will be okay. So and now what will happen, it will take all the similar things it got. Okay, like there are 10 sentences you got as similar, but Now what will happen? First we will sort them, and we will take the last two. Why we are taking the last two? Because it is sorted in the in what it is sorted in the ascending order, so like less similar to the most similar. Okay, so we are taking the last two, means we are taking the best two similar. Okay, so this sorting we will sort this most similar. Okay, now we will flatten, and we will flatten the vowels, this similar ones. Okay, and then we will sort again, or we can also ignore this part, just for the more approximate, like more appropriate responses, we are flattening it. And then we will take the second last one, second last similar one, because I told you, like first similar may be the heading of the, like whole paragraph, first similar may be the heading of the whole paragraph. So I'm taking the less second last similar, like second most similar element. Okay, you even you can do, you even you can append all the similar part here. You can append every similar you got, you can append here. Okay, but just for the experimental purpose, I have taken only the second most similar element. So it went here, it will find the most similar element and store in the bot response as a list. If bot response list is not empty, okay, if there is something in the list bot response, then it will return the first element. Otherwise it will return the bot response, means it will return, I didn't under I am not under I am not able to understand you. Okay, and and then after the whole process, when bot response is returned, it will remove your new sentence and the old data is preserved, like old data is not changed. So that's why we are removing the new sentence, because why do we need to use why do we need to add this in a whole data set? Okay, so we are just removing this from the data set at end. That's all. Any more question, or did you understand, or any more issue? Any more issue? I'll be sharing, if you want, then I can share you the codes as well as the whole workflow. I can wait, I'm sharing the whole workflow for now. Yeah, so you can access this workflow. If any question in the workflow also, you can ask me, if any step you want. If you are thinking like how it is converting into the matrix, so this part is that, so TF and TF has the fit transform which converts your tokens into the whole matrix part. Okay, and then you are taking the whole thing into the consideration. Any questions, any queries on any of the part, like PPT or workflow or code? Should be only related to the text we entered in it. Yeah, every chatbot is trained on some data. Okay, like if you see the LLM models, it is also trained on the various parameters. Okay, so without data, if you don't have data in any of the chatbot, if you ask what is Samsung phone on Zomato chatbot, it won't answer because the data trained on Zomato app is not having the Samsung data. So every chatbot only respond to the like only responds to the question to which data it is trained upon. Okay, so you need data for the whole process. So machine learning is only possible if you have well formed data. Okay, so every model in this world of machine learning is trained on some data. Even in neural networks, let's say example, if we come to example of what to work, I will show you. See what happen here. You take the data here. Wait. Okay, let's I will whiteboard. Okay, I will tell you example. Even in neural networks, if you have a data like 0 0 0 0 1 0, okay, and one, it is it depends on your data. It's if you are having lakhs of word, the dimension will increase. Okay, and you give the data here. Like if you give 0 1 2 date, if you give 0 1 0 as a data, then it will compare from, it will take 1 0 and it will compare all three 0 1 0 if you have. Okay, so let's say if you have the data and if you give this data to the neural network, so what it does, it will take this part and it will compare to every part. Okay, and then a new response array will be formed, or you can response box will be formed, where it will store the similarity. Okay, if a 0 0 0 0, okay, it will take this part and store here. Again it will do again to the whole thing. It will iterate to the whole, it will compare everything. So you need data for everything in machine learning. Any more questions or uh, uh, did you understand what I told, everything, or any part to be repeated? You can tell me. Yeah. So I try to explain in the most simplest language I ever heard or read. So if you want to, if you want the code, I can share you. Okay, I will tell the Alan Thomas. He will share you the code after some time. Yeah. Also, last some more part, like here we have used the TF-IDF, which is in the scikit-learn, which is machine learning thing. Okay. So we can also use a what to wake here. What to wake is a deep learning model where more like it is more advanced than TF-IDF. It is based on the neural network which I explained earlier. I'm getting this. Yeah, this is the part. This is a continuous bow of words. Okay, so how it works is it have you heard about the window sliding method now? So it slides after every word it get, so it will take the context word at the first and third word, and it will take the middle word as a target word. Okay, so after this it will store in this word, it will take this as inputs, context word as input, and the target as output, and this will be stored in like this table. This table you have seen in machine learning models for predicting predictive models. You have heard, you have seen this data which you convert into OHA, one hot encoders. Okay, so now what it will do, it will take this three things. Okay, and it will come here. This three things will come here, and these, like every part you took, it will take first here, and the second one here, and the these three things you will get from this one. Okay, and it will compare every part here. Like if it is 5 and is 3, it will compare 15 times. Like it will first 1 2 3, and now it's second part 1 2 3. Like here you can see there is data, what sports for, what sports for data science. Like this is the probability we are getting. Okay, if we are getting, if we don't get any, or we are, if we don't get any word, like here are some different word and here are some different word, we backtrack again and again we compare and go. So this is how a basic ANN or neural network work. Okay, so these dots are called perceptron. If you don't know, I'm telling, these dots are called perceptron, and this contains the data you are putting in it. So these are having two three features. Like if you perceptron, if you, this is the perceptron now, then the value of the perceptron will be W1 plus W2 plus W3. Okay, so this is the neural network part. Okay, so this is the basic one. So any more questions? Also one more thing, like here I used lemmatization, no? Stemming is more better than lemmatization. Also it supports the different languages also, like Potter stemmer and the snowball stemmer. Okay, Potter stemmer for English and the snowball stemmer for the, other languages. It will do the same thing. It will this will be converted into a single sentence walk. So there's like similar lematizer we use now from sklearn library. Sorry, NLTK.stem. Here same thing we have Potter stemmer, where we can do the same thing, but stemmer Potter stemmer is more fast than lematizer because of the inflection, which is because it is the algorithm in it. It compares the word, it uses also the mapping thing. Any more questions? Also, you have seen the mini PDF reader thing, which are used on the LLMs. You can search about the LangChain thing. So what LangChain is, it connects your LLMs into the custom bot or chatbot. You can even use that for more advanced chatbot as well, or any PDF reader, document readers. Okay, and also one more application I will tell, which you can try using this code only. You can take any video from the YouTube, you transcribe the video, okay, and you add into the this data set. Okay, and then you can ask the questions from the video. You can make a script out of that, and this small project you can do it yourself. Take a video using GTTS is, I think, library in Python, or movies.py, movie.py libraries in Python, which you can convert the video or into the text. Like you have to take out the audio file and convert that audio into the text, and then put that text into this thing, and then you can easily talk to the video itself. Okay, so this is also one project you can try using these same codes. And also, like you have seen the Google search engines or any search engines. So what it does, search engines, if you have made any website, they are meta tags for meta tags for giving your website a description in the search engine. So what Google do, they index your website according to the meta tags you gave it to them. Okay, so they store the meta tags into a database. Okay, they store the meta into a database, and then when you give response, when you ask something from Google, hi, I want to know about VIT. So what you, the same pipeline, the Google search engine or any search engine will follow. It will tokenize your word, and it will search in the database for the meta tag. Okay, if you developed any website, or if you will see any SEO thing, they are using meta tags for this purpose only, for indexing their site, so that the users when search for them, it search into that into that database, and it will search for the meta tags. Okay, so if you are giving the VIT, it will search for VIT, all the meta tags in VIT. It will take all the responses or all the similar responses, and it will provide you all the similar web URLs to you. Okay, so you understood what I am telling now? Like meta tags are generally used for this purpose only, for optimizing. So the better you give and the accurate meta tags you provide in the website, the better search results will appear to you. So in web development, also in SEO optimization thing, this machine learning models or deep learning models are also used. As the data is very large, so there they use the LLMs and also the neural networks of big models. So for the short thing, you can also use this type of machine learning TF-IDF models or word-to-vec models. Okay. So these are some application, real world application where we are using this NLP thing in real time. Okay. And also machine learning don't work. Also machine learning don't work on the characters and the words. So everything has to be converted into numbers. Okay. So similarity thing, everything has to be converted into numbers, where it will, in also neural networks, at some point of the time, the your data or every data is converted into numbers, and so that the similarity is more better. Even now the most proper natural understanding is not developed in any neural networks. You can search any articles out of that, or okay. So it is better to work with numbers for now. In future, may advanced technologies can come which can work directly on the words given. No need to convert it into the numbers, okay, digits or arrays. So any questions, any doubts?
Yeah, it was a great session, Harsh. If there are no doubts for everyone, you can wind up.
Yeah, so thank you everyone for attending this session. You can give some feedback in the informal group as well. We'll appreciate it. Thank you. Yeah, so I'm ending this session. No.
Yeah, Harsh.
Yeah, bye bye, good evening.